Welcome to SK Study Corner. In today's session, we'll be diving deep into Chapter 1 of Class 10 Science, Gravitation. From Newton's law to Kepler's discoveries, from free fall to escape velocity, we'll cover every concept with diagrams, formulas, and real-life examples. Whether you're preparing for the board exam or just want to understand gravitation in a simple way, you're in the right place. Let's get started. Gravitational force is a universal force that acts between any two objects, not just on Earth, but anywhere in the universe. Sir Isaac Newton first discovered this force after observing an apple fall from a tree. He wondered why it fell straight down and concluded that the Earth pulls the apple towards its center. This attractive force is what we call gravity. Newton's law states that every object attracts every other object with a certain force. This force increases with mass and decreases with distance. Mathematically, it's expressed as F equals G times m1 times m2 divided by d squared, where G is the universal gravitational constant. The strength of gravity depends on mass and distance. Double the mass, and the force doubles. Double the distance, and the force becomes 1/4. Gravity always acts along the line joining the centers or centers of mass of the two bodies. That's why the shape and structure of objects also affect gravitational interactions. Before Newton, Johannes Kepler studied planetary motion. By analyzing astronomical data, he discovered 3 laws describing how planets move. These laws helped Newton understand and mathematically explain the law of gravitation. Kepler's first law says that planets move in elliptical orbits, not perfect circles, with the Sun at one focus. An ellipse has 2 foci, and the planet's distance from the Sun varies as it moves along its path. The second law states that the line joining a planet and the Sun sweeps equal areas in equal time intervals. This means a planet moves faster when it's closer to the Sun, and slower when it's farther away. The third law shows that the square of a planet's time period is directly proportional to the cube of its average distance from the Sun. So, t squared is proportional to r cubed. This helped Newton understand that gravity weakens with distance. When you spin a stone tied to a string, the force pulling it toward the center is the centripetal force. If you let go, it flies off tangentially. In space, gravitational force acts as the centripetal force that keeps planets and moons in orbit. Objects near the Earth experience an acceleration due to gravity, denoted by small g. It's about 9.8 meters per second squared and is directed toward the Earth's center. The formula is g equals gm divided by r squared, using Earth's mass and radius. Gravity isn't the same everywhere. It's slightly stronger at the poles and weaker at the equator due to the Earth's shape. G also decreases with height above the Earth and depth below the surface. On the Moon, G is about 1/6 of Earth's. Mass is the amount of matter in an object and stays constant everywhere. Weight is the force of gravity on an object and is calculated by W equals mg. Since G varies, so does weight. People often confuse mass and weight, but scientifically, they are not the same. Free fall occurs when an object moves under gravity alone. All objects accelerate equally, regardless of their mass, in the absence of air resistance. Galileo's famous experiment proved this by dropping 2 objects of different masses. They hit the ground together. Gravitational potential energy is stored due to height. Near Earth's surface, it's mgh, but for large heights, we use -gmm by r plus h. Escape velocity is the minimum speed needed to overcome gravity completely. For Earth, it's about 11.2 kilometers per second. Astronauts appear to float in space, not because gravity is 0, but because they're in continuous free fall around Earth. They, and their spacecraft, fall together at the same rate, creating a sensation of weightlessness. Thank you for watching. We hope it helped you understand the concepts clearly and boosted your confidence for exams. Don't forget to like, share, and subscribe if you found it useful, and keep exploring the wonders of science.